Mathematics is the science of structure, order, and relation that has evolved from elemental practices of counting, measuring, and describing the shape of objects. It deals with logical reasoning and quantitative calculation, and its development has involved an increasing degree of idealization and abstraction of its subject matter. I'm Sir Phil na nagsasabing, palaging piliin mong matuto.
Good day everyone, this is Sir Phil, and today in our mathematics class, we're going to discuss a new lesson entitled Angles of Elevation and Depression. Before we proceed with this lesson, let us have our lesson objectives. In this lesson, you will illustrate the concepts of angles of elevation and depression. Identify angles of elevation and depression in real-life scenarios and diagrams. Solve problems involving angles of elevation and depression. To start our today's session, let's start with our project all numerates. For today's project on, we're going to write the following ratio in simplest form, given the following situations. I want you to get a scratch paper to write your answer. The first situation is, a fruit salad recipe calls for a ratio of 2 parts strawberries and 4 parts bananas. Ready? Okay. The ratio for this situation in simplest form is 1/2 or 1:2. Second situation. A painter needs to mix paint colors in a ratio of 3 parts blue paint to 9 parts white paint to achieve the desired shape. Write the ratio in simplest form. Okay, so the answer for this is 1/3 or 1:3. Make sure that you write the ratio in simplest form. Next, mechanical advantage represents the ratio of output force of 80 newtons to input force of 20 newtons in a simple machine. Write the ratio in simplest form. Okay, so the answer for this situation is 4:1 or 4/1. Next, in economics, the ratio of inputs to outputs is important in production processes. A company produces 150 units of a product using 50 units of labor. Write the ratio in simplest form. Okay, so the ratio in simplest form is 3/1 or 3:1. We'll go over with more ratio-related situations along with our lesson for today. After this project on, let's proceed for our project square. For today's project square, welcome adventurers to the lush and captivating world of Mount Balagbag in San Jose del Monte, Bulacan, where nature's beauty meets the rich cultural heritage of the Umaga tribes. Nestled amidst the verdant landscape of the Philippines, Mount Balagbag stands as a testament to the symbiotic relationship between man and nature, where every trail tells a story of resilience, stewardship, and reverence for the land. Allow me to read a particular passage about the Mount Balagbag in San Jose del Monte, Bulacan. And later on, I will show you how beautiful Mount Balagbag is through a particular video. Allow me to read the passage. Mount Balagbag, situated in San Jose del Monte, Bulacan, is a prominent landmark boasting an elevation of approximately 777 meters above sea level. This towering peak serves as a beacon of cultural significance for the indigenous Dumaga tribes inhabiting its foothills. For generations, the Dumaga people have revered Mount Balagbag as a sacred site, intertwining their spiritual beliefs with the mountain's lofty elevation. The mountain's height not only offers taking panoramic views of the surrounding landscape, but also symbolizes the Dumagat's deep-rooted connection to the land and their ancestral heritage. Here is a particular video when I go hiking from Mount Balagbag. To embark in this journey, prepare to be immersed in the wonders of the Dumagat tribes. The indigenous people have called these majestic mountains their home for centuries. Their deep connection to the land is palpable in every step you take as you traverse through ancient trails adorned with whispers of tradition and folklore. To continue, let us answer the following questions about the passage. First question. What is the elevation of Mount Balagbag above sea level and why is it significant for the Dumagat tribes? Very good. The elevation of Mount Balagbag is approximately 777 meters above sea level. This height is significant for the Dumagat tribes because it symbolizes a sacred site deeply intertwined with their spiritual beliefs and ancestral heritage. Let's proceed with the next question. How have the Dumagat people revered Mount Balagbag over generations? Very good. Over generations, the Dumagat people have revered Mount Balagbag as a beacon of cultural significance. The Dumagat people have revered Mount Balagbag as a beacon of cultural significance, and they have integrated their spiritual beliefs with the mountain's lofty elevation, considering it a sacred site that represents their deep-rooted connection to the land. For our last question, besides offering panoramic views, what does the height of Mount Balagbag symbolize for the Dumagat tribes? Very good. The height of Mount Balagbag symbolizes more than just breathtaking views for the Dumagat tribes. It represents their profound connection to the land and their ancestral heritage. The mountain serves as a symbol of reverence and cultural identity for the indigenous Dumagat people inhabiting its foothills. Now you know how important the Mount Balagbag for the Dumagat tribes. That's why it is also important for us to preserve this Mount Balagbag as our one of the tourist spot in San Jose del Monte, Bulacan. Speaking of elevation, let us now proceed with our lesson. Let's start with the review of the different ratio in trigonometric functions. Given this illustration with the reference angle and the parts of a particular right triangle, the hypotenuse, the adjacent side, and the opposite side, I want you to write on your show me board the ratio of the following trigonometric functions. Are you ready? Let's start. For the first one, write the trigonometric ratio of the function sine theta. Boards up. The correct answer is opposite over the hypotenuse. Next, cotangent theta. Boards up. The correct answer is adjacent over opposite. Next, secant theta. Boards up is equal to the ratio of hypotenuse over the adjacent. Next, cosine theta. Boards up, this is equal to the ratio of adjacent over hypotenuse. Next, tangent theta. Boards up, tangent theta is equal to the ratio of the opposite side over the adjacent side. And finally, cosecant theta. Boards up, the cosecant theta is equal to the hypotenuse over the opposite side. Congratulations! This is a review of our 6 trigonometric functions with their corresponding ratio. Let us now proceed with our lesson. We will go over first with the angle of elevation. Let us define what is an angle of elevation is. An angle of elevation is the angle formed by a horizontal line and a line of sight to a point above the line. In this diagram below, angle 1 is the angle of elevation from the tower T to the plane P. As you can see, the broken line here is the line of sight. The angle of elevation is above the line of sight. So therefore, angle 1 is considered as an angle of elevation. The other one is the angle of depression. An angle of depression is the angle formed by a horizontal line and a line of sight to a point below the line. The angle 2 from the diagram is the angle of depression from the plane to the tower. As you can see, the broken line along with point P on the plane, the angle below is what we call the angle of depression. As you can see from the illustration, since the horizontal lines are parallel, angle 1 and angle 2 are congruent. As you can see, the two line of sight from point P and point P are parallel. It means that from the alternate interior angles theorem, angle 1 is congruent to angle 2. Therefore, the angle of elevation from one point is congruent to the angle of depression from the other point. Let us identify with the following situation if a particular angle is an angle of elevation or an angle of depression. Giving the illustration from the right side, let's start with angle 1. As you can see, the broken line is our line of sight. Angle 1 is below the line of sight. So therefore, angle 1 is formed by a horizontal line and a line of sight to a point below the line. Therefore, it is an angle of depression. Let's have angle 4. Again, the broken line with angle number 4 is our line of sight. As you can see, angle 4 is above the line of sight. Therefore, we consider angle 4 is formed by a horizontal line and a line of sight to a point above the line. Therefore, it is considered as an angle of elevation. As you can see, all we have to do is look at the line of sight. If the angle is below the line of sight, it is an angle of depression. If the angle is above the line of sight, it is an angle of elevation. Let's try angle number 2. As you can see, the line of sight is between angle 2 and angle 3. Since angle 2 is above the line of sight, it is considered as the angle of elevation. Let us consider another illustration here. Use the diagram above to classify each angle as an angle of elevation or an angle of depression. Let's see angle number 5. Again, the broken line with angle number 5 is our line of sight. As you can see, angle 5 is below the line of sight. It means it is formed by our horizontal line and a line of sight to a point below the line. Therefore, it is considered as an angle of depression. How about angle 6? Again, the line of sight is a broken line with angle number 6. As you can see, angle number 6 is above the line of sight. Therefore, angle 6 is formed by a horizontal line and a line of sight to a point above the line. Therefore, it is considered as an angle of elevation. Do you know now the difference between angle of elevation and angle of depression? If so, let us proceed with the problem solving involving angle of elevation and depression. Let us now consider the figure or the illustration below. We are asked to name the angle of depression or angle of the elevation in each figure. We have your angle FLS, angle LST. For letter B, we have angle RTW and angle TWS. For the illustration C, we have angle DCB and angle ABC. For illustration D, we have angle WZP and angle ZPR. Remember that the horizontal lines on the illustrations are considered as the line of sight, and the angles below and above them are the angle of depression or the angle of elevation. You are now to identify which of the two given angles for each illustration are angle of depression or angle of elevation. Very good. As you can see from the illustration, all angles written in red colors are considered as angle of depression, while the angles written in blue colors are the angle of elevation. Very good. You are now ready to solve problems involving angle of elevation and depression. Let us now discuss the following problems involving angle of elevation and depression. The Seattle Space Needle casts a 67-meter shadow. If the angle of elevation from the tip of the shadow to the top of the Space Needle is 70 degrees, how tall is the Space Needle? Round to the nearest meter. In this particular manner, we're going to use a scientific calculator. But before we proceed with that, let us have the illustration for this problem. As you can see, angle A here is 70 degrees. And we have here a horizontal line below that is considered our line of sight. Therefore, angle A here is the angle of elevation to point B at the top of the Space Needle. This is a right angle since we have a square corner. So for this problem, we are looking for the height of the Space Needle. Since we consider the angle of elevation, which is 70 degrees, as our reference angle, the height of the Space Needle is considered as our opposite side. And the horizontal line or the line of sight here is considered as the adjacent side of angle A. If we are dealing with the adjacent side and the opposite side, what do you think is the particular trigonometric function we're going to use to solve this problem? Very good. We're going to use the tangent, because tangent is equal to opposite over the adjacent side. By that, let us write the equation as tangent 70 degrees as our reference angle equal to the opposite side, which is equal to y, which is our representation for the height of the Space Needle, over 67, which is the shallow Space Needle cast a 67-meter shadow. To solve that will be equal to y and the cross product of 67 and tangent 70 degrees. And that will be equal to y equal to 67 tangent 70 degrees. By calculating using our scientific calculator, we will get an approximately 184.08 meters. So therefore, the height of the Space Needle is 184.08 or 184 and 800 meters. Let us now proceed with the next problem. Maria is at the top of a cliff and sees a seal in the water. If the cliff is 40 feet above the water and the angle of depression is 52 degrees, what is the horizontal distance from the seal to the cliff? First, let us illustrate the problem. As you can see, Maria is at the top of a cliff, and the line of sight is the pink broken line or the line AB. As you can see, the 52 degrees angle of depression is below the line of sight. And as I said a while ago, the angle of depression, angle A here, and angle C, since AB is parallel to DC, are alternate interior angles. So therefore, angle A and angle C are congruent by the alternate interior angle theorem. So if angle A is 52 degrees, angle C is also 52 degrees. So we will use now the reference angle, which is equal to 52 degrees inside the triangle. As you can see, the 52 degrees here is opposite the height of the cliff, which is 40 feet. And we are looking for the distance or the horizontal distance of the seal from point C to the cliff. So from the reference angle given by the 52 degrees, the height of the cliff, which is 40 feet, opposite from the reference angle. And as you can see, the side X here, or the line DC, or the horizontal distance from the seal to the cliff, is the adjacent side of the right triangle. So if we are to analyze it, we are going to use the opposite side to get the adjacent side. Again, what particular trigonometric function are we going to use to solve this particular problem? Very good. We're going to use again the tangent function. So given that the tangent 52 degrees as our reference angle is equal to the opposite side of this angle C, which is 40 feet, over the adjacent side, which is represented as X. To get the value of X, or the horizontal distance from the seal to the cliff, we use this equation. This is now X equal to 40 over tangent 52 degrees. Using our scientific calculator, we calculate for the value of X by 40 divided by tangent 52 degrees. And we will get X equal to 31.25 feet. So therefore, the horizontal distance from the seal to the cliff is 31.25 feet. We are now ready to solve more problems involving angle of elevations and depression. But for now, let us have a group activity. You are to form 5 groups with 8 members and solve for the following problems. Each group will present their solutions after 5 minutes. Are you ready? Here is the first problem. At the circus, a person in the audience at ground level watches the higher wire team. A 5'5" tall acrobat is standing on a platform that is 25 feet off the ground. How far is the audience member from the base of the platform if the angle of elevation from the audience member's line of sight to the top of the acrobat is 27 degrees? First, make sure that you draw the right illustration for this problem. Now do it with your group members. To help you, this is an example of an illustration for this particular problem. As you can see, we have the 27 degrees as our angle of elevation above the baseline, which is PQ. And opposite to it is the side QR plus a 5 foot 5 inch tall acrobat, which is the side QS. What do you think is the trigonometric function that could help us to find the base of the platform? Are you ready for the presentation? Very good. It is the tangent theta. So we use the 27 degrees as our reference angle. So that is tangent 27 degrees equal to QS, which is the add up height of the platform and the 5 foot 5 inch tall acrobat, over PQ, which is our base of the platform. So we are looking for the base of the platform. We also represent it as side X. So by substitution with the given data, tangent 27 degrees is equal to 30.5. 30.5 came from the sum of the height of the platform and the 5 foot 5 inch tall acrobat. That is 25 feet plus 5.5 feet. And that is equal to 30.5. So we will use 30.5 as the sum of the height of the platform and the 5 foot 5 inch tall acrobat. And that is our opposite side of the reference angle of 27 degrees over X, which is the side PQ, or the base of the platform. To solve that, that is equal to the cross product of X and tangent 27 degrees. X tangent 27 degrees equal to 30.5. To isolate X, since we are looking for the value of X, we divide both sides by tangent 27 degrees. X is equal to 30.5 over tangent 27 degrees. Using our scientific calculators, that is equal to approximately 59.9. X is approximately 59.9, or that is the how far P from Q. For our next problem, be ready for your groupings. A ranger sees another fire at 90 feet height and the angle of depression to the fire is 3 degrees. What is the horizontal distance to this fire? First, you need to draw the right illustration for this problem. As you can see, the reference angle 3 degrees is below the line of sight. So therefore, it is an angle of depression. Again, the angle below the line of sight is equal to angle F, since the horizontal line of sight and the side SF is parallel to each other. So therefore, angle T and angle F are congruent. So angle F is also equal to 3 degrees. So from this reference angle, the 90 feet here, which is the height of the ranger, is opposite with angle F. And we are looking for the horizontal distance, which is the side SF, which is also represented as X. And this is the adjacent side. So therefore, we're going to use the tangent theta. Tangent 3 degrees is equal to 90, which is the opposite side, over X, which is the adjacent side. Following the equation, this is now equal to x equal to 90 over tangent 3 degrees. Using our scientific calculator, we divide 90 by tangent 3 degrees, and we will get the approximately 1,717 and 30 hundredths feet. We are done with solving problems involving angle of elevation and depression. Let us now proceed for our practical applications of this lesson following our oral language fluency involving the solar panel installation in the Philippines. From our previous class survey, at least 10% of you are having a solar panel at home. In a bustling neighborhood in Barangay Gaya-Gaya, the Reyes family is keen on harnessing renewable energy to power their home. With a scorching tropical sun as their ally, they embark on a journey to install solar panels on their rooftop to reduce electricity costs and minimize their carbon footprint. Let us discuss this particular topic about the solar panel installation in the Philippines involving an angle of elevation. Let us answer this particular question. How does the angle of elevation impact the efficiency of solar panels in harnessing sunlight for electricity generation? To those who answered yes that they have solar panel at home, you can answer this particular question. Very good. The angle of elevation determines how directly the sun's rays hit the solar panels. We want to maximize sunlight exposure to generate as much electricity as possible. They assess the optimal angle of elevation for their solar panels. They research the ideal tilt angle based on seasonal variations in the sun's position. They adjust the tilt angle to capture the maximum sunlight during peak hours, taking into account factors like roof slope and nearby shading. They secure the panels firmly to the rooftop, ensuring they face southward to align with the sun's path across the sky. And that's how we use solar panel installation at home. To generalize our lesson for this session, identify between the indicated angles as either angles of elevation or angles of depression and provide reasons for each classification. Here is the illustration. Very good. From the illustration, angle 6 and angle 8 are angles of depression because they are angles formed by a horizontal line and a line of sight to a point below the line. And angle 7 and angle 9 are angles of elevation because they are angles formed by a horizontal line and a line of sight to a point above the line. Very good. So let us now proceed with your evaluation. Answer the following problems using the Sakatawa or a particular trigonometric function to solve these particular problems. Number 1. A plane is flying at an altitude of 14,500 feet. The angle of depression from the plane to a control tower is 15 degrees. What is the horizontal distance from the plane to the tower? Round to the nearest foot. Number 2. The Seattle Space Needle casts a 67-meter shadow. If the angle of elevation from the tip of the shadow to the top of the Space Needle is 70 degrees, how tall is the Space Needle? Round to the nearest meter. Get ready your pen and paper to solve these problems. After solving the problem, we have our home task challenge problem. We're going to solve it at home. Let's read first the problem. An observer in a lighthouse is 69 feet above the water. He sights two boats in the water directly in front of him. The angle of depression to the nearest boat is 48 degrees. The angle of depression to the other boat is 22 degrees. What is the distance between the two boats? Round to the nearest foot. And there you have it, our lesson about the angle of elevation and depression. We will check your assignment on our next session. Again, this is our Phil, and thank you for listening. See you on our next Mathematics 9 session.
Mathematics is the science of structure, order, and relation that has evolved from elemental practices of counting, measuring, and describing the shape of objects. It deals with logical reasoning and quantitative calculation, and its development has involved an increasing degree of idealization and abstraction of its subject matter. I'm Sir Phil na nagsasabing, palaging piliin mong matuto.